everybody. Paulchin Jr. here. Today, we're on an episode of Talking Serverless, where we talk about serverless. And my guest today is Richard Boyd. He's been in the serverless space for as longer than I have been, and I'm really excited to have him on the show. He's been working diligently to create better tools and create better experiences for all developers in serverless. And today I have to pull in the hot, dreaded buzzword of AI, because if we don't talk about it, then I think we're going to end up building all the wrong things. So, with that, Richard, why don't you introduce yourself to our audience and give them a bit about what you've been working on this last couple of years?
Yeah, so my name is Richard Boyd. I've been in the serverless developer tools space for yeah, since 2016 ish. It really started when I was on Alexa and we were migrating some of our infrastructure from internally inside of Amazon to what we were calling native AWS, where each team had their own account. And we took some of that opportunity we saw some benefits in migrating to a more serverless architecture. And in doing that migration, I saw a lot of huge gaps in the tooling that existed there for interacting with it, which led me into CDK, the Cloud Developer Kit, which is a tool for developer experience, make it easier to craft infrastructure. Specifically, at that time, it was CloudFormation, and then I guess from there, I joined AWS as a developer advocate, product manager in the developer tools org, and then I've worked on a few projects that they've launched: Code Catalyst, Code Whisperer, Cloud9, uh, and most recently QChat.
So it seems like you're just like on the forefront of taking these services that have tons of potential, but still need a lot of like smoothing out of rough edges and then turning those into tools, right? So you mentioned stuff like CDK, and CDK, for in my experience, has been both good and bad and confusing, but over time it's gotten better and better, and I think it's because of the work of folks like you. While you're making these tools, what kind of things are you trying to fix or make better for developers with those tools?
I would argue I'm going to be a rude guest. I'm going to push back ever so slightly. So I'd say CDK got better not because of me, but because there's I forget his last name. His name's Roman. He's from France, or he lives in France. He used to work at AWS, but now I believe he's at Databricks or Datadog, one of the data companies. And he did a lot to really you have this issue with CDK specifically on it takes code from your preferred language and then kind of transpiles it into CloudFormation. And there's weird idioms people talk about, like the Pythonic way of doing something, which is much different than the whatever the Java idiom, the term for Java idioms are. So Java's real big on builders, right? Like the builder pattern of dot add this, dot add that, dot add that, dot build. That's kind of a foreign concept in Python. Python takes a lot of default constructor kind of different approach. And Roman did a lot of work to make the Python CDK feel more intuitive to Python developers. So I wanted to start the show by disagreeing with you, but I think that does highlight work that people should do in general to make these tools better. You have a way to improve the experience or to provide a better experience, but you still need to kind of bridge where people are. They still expect a intuitive Python interface or intuitive Java or C Sharp or Ruby interface that you can't say, hey, this is going to make your life so much easier. Ignore all the things that you're comfortable with and just learn our way. I don't want to use a term like meet developers where they are, but it is a bit of that, of kind of meeting them halfway. I think that's one of the biggest, it's one of the highest return on investments areas where developer tooling builders can invest to improve the experience of their tools.
Okay, so I mean, if you want to really get, did CDK come about because all the JavaScript kids were having all the fun with AWS and infrastructure, while the Java and Python people weren't able to participate in all the fun frameworks?
Not as much. I think that when we when we first launched it, the thought was that like if we make it easier for kind of self-described quote unquote full-time engineers, software engineers to kind of manage their infrastructure the same way that they would manage an application. Write write very similar Java code. So you already have like your test frameworks. You can use JUnit. You can use Nose. I forget the other Python testing, GS. Some of these other you already are familiar with those testing frameworks. You don't have to rebuild those for CloudFormation. So we really thought that CDK would allow I use this term very loosely, like professional software engineers to like better manage their infrastructure. And after we launched it, we had realized that the people who were actually picking it up much more quickly were ops people who wanted to automate the stuff that they were already doing. So it wasn't that we made it simpler for dev teams to take over more of the ops. We made it so that ops teams can leverage some like dev practices to make them much more efficient, which is why like the Python and JavaScript version, like the uptake on those languages just exploded much faster than Java and C Sharp. And because of this, like if you go into a random like ops team, they're going to know Python much better than Java. They're going to know JavaScript much better than C Sharp, just because those are like the common scripting tools people use, and they work across all these platforms.
That is awesome that you can bring these tools for the ops people, right? And I feel like over the last 6 years, it's been nothing but trying to get developers to try to think more about their infrastructure state, and the operators and the DevOps folks to think more like an application developer at the same time. And I've always thought that it would be easier, but it really hasn't. Like, we do you find that adopting CDK and adopting infrastructure as code in general has been more of an uphill battle than you thought?
Uh, yes, I think what them in the because we're on the serverless podcast, the draw of serverless is that you don't have to manage, you don't have to worry about the infrastructure, right? It just scales automatically. But even if you're using an infrastructure as code tool, you still need to think about like how much memory am I allocating to this Lambda function, and thereby also like how much CPU, I mean, virtual CPUs are assigned to it. Uh, how do I like logically break this thing up to run on like separate function versus a function that's been warmed up and has some kind of local cache or other things. So you still end up doing a lot of thinking about infrastructure, even if it's not thinking about provisioning physical hardware or even like EC2 instances. That I get that the North Star, the tenet of serverless is you never have to think about infrastructure again. But no matter where you go, you're gonna like it has to run somewhere. The code has to execute somewhere. So you do have to give some thought to it. And I think it does a disservice when people really push this, like, oh, do serverless, never think about infrastructure again. Like you're it's I think Ben Keogh is an example of like it's like candy, right? Like you do still need to eat some of your vegetables. Of like you do have to think about where this is going to run and think about some of these like less sexy things about running an application.
Yeah, there's the complexity moves elsewhere. So it's not that it's completely gone; it's a different mode. But I think the thing that I've always enjoyed about infrastructure as code is that I can step back as a developer and actually see all the different resources that I'm deploying, and being able to have at least an inkling of like managing it on my own without having to like just sweat bullets 24/7 to know if something's working. Cool.
Yeah, yeah, that's one of the things I liked about like HashiCorp's like Terraform's approach with like the TF plan, where it'll tell you much more concretely or discreetly. These are the changes that are going to happen. You get some of that with like a CloudFormation change set, but there's still a little bit of like spray and pray of like, okay, deploy it and just like fingers crossed, we'll see how it goes. Like not being able to like a priori say like this is exactly what's going to happen at the end of this. I think is um, a a source a lot of psychological like uncertainty for developers who are doing any kind of infrastructure management, whether it's infrastructure as code or kind of manually updating the confirmation template in the console.
Yeah, there are a number of services in AWS that I use that I wish had better IAC tooling around. A lot of the newer stuff that they're trying out and folding in, especially stuff like QuickSight. Like, there's not really a good way to provision those kinds of things. Even step functions, from a certain standpoint, are harder to turn into IAC. There's still a lot of console manipulation after the fact to get it working just right. So there are lots of those little rough edges that could still be made better. There's still better tooling that could come, and that's what keeps me hopeful. I guess. Cool. So the big $10 billion questions are all around Gen AI, and even the term Gen AI, like now I'm saying it like it's like, oh, it's just so given, Gen AI. But no, it wasn't until reInvent this past year when I just saw the phrase Gen AI just everywhere, right? Have you Can you tell us about your experience kind of messing with it and seeing what's what?
I was part of the team that launched Amazon Q at reInvent last year before leaving AWS, and I learned quite a bit. My educational background is in applied math and statistics, and I always kept like a foot kind of in the machine learning space. So I understand, like, the way I describe it is I understand like the foundational concepts. Like, I understand how a neural net works. Like, mathematically, I can show you how the calculus works for it. But when someone's like, "Okay, do this thing in PyTorch," I'm like, I have no idea. It's like I don't know how to use this specific library. There was a lot of like the implementation details, especially around like retrieval augmented generation, like RAG, which is a super popular approach, and tokenization, and a lot of these efforts. I learned quite a bit in how these are built and more of the implementation side of it. And I think where I became kind of disillusioned to the value of it, where I think people are putting the proverbial cart before the horse on this, is that I see too many people wanting to. When I say people, I'm referring to like service providers or like SaaS providers. They want to like take a human language description of something. Let's say, if you want to go to Y Combinator and say, "Oh, we let someone describe their infrastructure with native, with a natural language, and then we will generate a CloudFormation template for them, or a Terraform like application, or Plumi application, like from that. We'll generate infrastructure as code from natural language, and then we give that to the customer, and like they can then take it and deploy it, which like sounds great on like first order, like a first pass of like, oh yeah, why wouldn't you want that? Why wouldn't you want someone to do all this for you? But my challenge to that is always either the code that you generate and you give to the customer, you either guarantee that it's correct, in which case, why not just deploy it for them? If you're going to guarantee that this code is correct and does exactly what you want it to do that you generated, why not just deploy it for the customer and just give them the infrastructure? Because that's what they want at the end of the day. They don't. Nobody actually wants a CloudFormation template. They want infrastructure, and the CloudFormation template is how they get it. But what I suspect, what's often true, is that people are worried about hallucinations and they can't quite guarantee that it's correct. So like, okay, well, we'll give them the template, and then the customer can decide. They can pick if it's correct, or if you want to be very cynical about it, say like, oh, well, then it's their responsibility to check and run their own tests and verify it. And on the one hand, you're saying, we'll use our generative AI thing to generate your infrastructure as code, so you don't have to worry about your infrastructure as code. But also, it might have this very subtle bug that you then have to know how to like spot and fix and guarantee that there's no regressions. In which case, like, you have to know how to use the infrastructure as code tool, and you have to like deeply understand it. How much time has a generative AI thing actually saved you in this case? If you have to be like very diligently searching it for like minor hallucinations. So that's where like I think before we get to a point where generative AI can be used for infrastructure as code tools, we need a better integration between things like automated reasoning and static analysis as part of the generative AI kind of pipeline, where it'll generate an application with generative AI, and then we can apply some of these static analysis, automated reasoning techniques to it to say, like, is this correct? Like, automated reasoning is real good at saying, I can prove this is correct, or I need more information, and this is the information that I need, which can then be fed back into the generative AI thing of like, oh, explain more about this, or like, here's a thing you didn't consider. Like, generative AI tools are really good at generating a lot of examples, and the automated reasoning tools are really good at sorting examples into things that are valid, things that are clearly valid, and things that need more information. And I think until we have a better integration between those two, the idea of generative AI based, like generating infrastructure as code or code in general, will be more of a novelty than a mainstream practice.
Hmm. That brings up a very good, look at what's possible with these tools. And I've been all over them since they came out because they're just fun to use. Like, I never thought I would be able to just sit with a prediction model and just play with it. It does a really good job of creating that back and forth. But like, to your point, how much time is that really going to save me if I try to make it do something specific, because the model itself is not deterministic. I don't have any math or engineering background, but I've watched a ton of YouTube videos now, and like relearned some calculus, and like understanding how the GPU in my computer is just multiplying lots of numbers and then squashing them to make a you know fit a line such that it always is between -1 and 1. Like, that's it. Like, it just takes a ton of numbers. We're able to use math to encode the like essence of a idea into numbers, smash those numbers into like this multi-dimensional topographic field, and then tell the computer to find minimums or maximums within that. um and like, all of it is very fascinating. And then I think our job as like communicators and technologists is to tell the regular folk out there that it's a very nice probability model. Like, it's always going to give you some probability of something happening, right? And you had mentioned something like the RAG architectures, and some of the ways that the Gen AI architectures are evolving. Could you tell us a little bit about what that architecture really looks like in practice on AWS when you want to have a like a Gen AI thing and you're using Bedrock and SageMaker and all that stuff? Can you kind of walk us through a typical architecture and use case?
Yeah, I mean, I give you like the marketing answer. Like, there's no typical architecture. Everyone is a unique pony, and no, but I think what the most common that I see, and this is like I've over the past few months, I've lost track a bit of a lot of the newer launches or like the most recent launches from Bedrock. But what we see is people will use some kind of a like a vector database. So I think Pinecone, which is a product that exists, not part of AWS. Milvis, I think, is another one. Zilla's. There's like two companies. It's like a company with an open source thing, and it makes up those two. But those are mentally I put those in the same bucket. And these are like vector databases. So what you'll commonly see is like I think Kendra is used frequently. Some of these like data stores. The idea is that if you want to just ask kind of ChatGPT a question, like that's easy, right? You just go to OpenAI and ask it a question, and that'll give you an answer that's based on open source, broadly available stuff. So if you have a tool that you want to make that just needs to know about things that are more or less publicly available, there's no special AWS, there's no special infrastructure you need. You can just use these things. But if you have like internal documentation that you want used and you don't want to, publish it on the information on the internet or do some of these other items, typically you will have those will go through some kind of a tokenization process that's based on the specific model that you're going to use, your large language model. The tokens, which end up being a vector of numbers between 0 and 1, generally, -1 and 1, again, depending on the model, and like the size of the token also depends on the model. Those are stored in a database, in a vector database, usually with like a reference to like the document that it came from. So not only do you have like the information that was encoded there, but you have metadata around like what document did it come from, when was it retrieved, what was the context in which it was retrieved, all this other stuff that is relevant to that string of text, but you don't want to put directly in the text itself. So metadata, and then when you someone comes along and they query your large language model application, you will go to the vector database, look for the nearest neighbors, other vectors that have been encoded and put in there, inspect the metadata to see if there's other information you need to retrieve, gather up all of that data of like the nearest neighbors, things that are most similar to it, add that to the context, and then put all of that into a large language model, and then get the response on the other side. And depending on the implementation, sometimes you'll also append these are the retrievals that we got from the RAG database, like the vector database. So you can say, because the LLMs hallucinate quite a bit of, oh, don't take our word for it, like go and check these specific sources, because sometimes they might say like the exact opposite, depending on how it was chunked and items like that. So that's like the typical flow, and there's different databases and compute you could use for this depending on what your architecture is.
All right. So it sounds like there's a lot of kind of like pre-computation that has to happen when someone really wants to take advantage of, I guess, specific knowledge that they want to inject into the model. And is that process something that is pretty straightforward, or are there a lot of gotchas that you got to figure out? Because when I think about it, I think, okay, what if I collect all the PDFs about Nicolas Cage movie reviews and I put them all together, and then I use the movie reviews in order to form some abstract idea of like what makes a good Nicolas Cage movie? Like, is like what will I be trying to pull and manipulate for this data?
So one gotcha that I think is the most common is, let's say you also include like the Nicolas Cage subreddit, and there's like threads of content of comments back and forth, right? Someone makes a comment, someone replies, and you have the string of replies. One part is like what's called chunking, is where the thing that you tokenize and put into your vector database, one option is you have it just be like, in this example, like a single comment can be like tokenized and then put into the database. So this is a thing someone said. But then you might want to know, well, actually, I want like that comment, and like I need to know who they're replying to have the context, so they might reference the same thing. So okay, well, a chunk will now be, a comment, and all of its parent comments to have this full context. So you might say, okay, well, I'm going to chunk each comment and I'm going to put that in the database. I'm going to chunk each comment with its parent, and then each comment with its grandparent, like parent and grandparent, and etc. So like that, you have this thing that you want to store one time, but you have to end up having to store it multiple times. So deciding what your like chunking strategy is a thing people don't often think about up front, of like, how do we chunk this? We see with some like code generation approaches, people will just like split it on like the, to the beginning of the line, if you're talking about code, like LLMs for like code generation. So it's like, the entire previous line to find similar lines. Um, the most recent like double new line, like blink line that exists, and that to me is like the most obvious gotcha. The process for like doing that, once you settle on these like business rules of like what we're going to consider a chunk that gets tokenized, and it is also limited by like the size of the context window. If the specific large language model you're using only supports a context window of like 1,000 tokens, then your chunks have to be by definition smaller than 1,000. But if you're using something with like 1,000,000 tokens, then you can have larger. So that, depending on your model, you might have more flexibility. And then once you've like settled on like how big your chunks are going to be, it's fairly, I would say, straightforward. And like you could describe it in like a state machine or a step function of, get this, have it run periodically to get new data and parse it, and fairly deterministically, process documents as they come in and place them in the database. The challenge then becomes reproducibility. If you do an LLM, you interact with the LLM system and get a response, and then you come back 2 days later, you might get a different response from like the generic stochasticity of how these LLMs work, or because like more data has been put into the database, and the k nearest neighbors are now different nearest neighbors, and it's using different context in the thing, and there's not much visibility into that as a user of the system of like, why am I getting a different answer? Is it genuinely a better answer, or is this just broadly close enough that it's roughly as accurate?
Yeah, I do see that when I talk to other people about using LLMs. Like, I have no problem using them. Like, I love using them. I can kind of feel where it's hallucinating and kind of steer it to do what I want. It's more of a collaborative thing. But then when I go to build production apps where I want a specific answer properly every single time, all of my time is spent reducing the context window, and it kind of like just removes all the creativity like out of the model. I spend time basically making it hallucinate as much as I can and then scaling it back until I know I can bind it properly. It's almost like an incantation of a demon. I just have to draw my pentagram on the ground just right so that it won't, blow up grandma unexpectedly somehow. Um and with all of these new tools, like, does serverless have a place in it? Like there's ephemeral, on demand compute mixed with heavy compute with weird state models. Like, how are we gonna, like, what does it mean for us?
Yeah, I think that where the generative AI is going to be the most useful is like the way I described generative AI when it was kind of when Copilot was the only kind of player in the space when we're talking about things related to generating code. Is that what makes these things like easy to demo and what makes them useful are two wildly different things, right? So if I were to tell you, I will give you $1 million if you can predict what the transcript will be of a demo for a generative AI coding application, you could probably do that, right? You could say, oh, okay, well, what they're going to do is they're going to say, watch this. I'm going to type a comment and press enter, and it's going to generate this leak code medium problem solution, right? Like that's every demo with generative AI is for coding does this, right? Because it's demos really well. Everybody understands. Well, not everybody, but like, enough people understand like why balancing a binary tree is an annoying problem, and you don't want to have to do it a bunch. That you can just say implement a function that balances a binary tree, and then like press enter. And there's so many code examples on the internet that it probably just pulling one of those like a really good page rank search algorithm will probably find that just as well as generative AI will, but it demos really well. People deeply understand that. But when you ask people who are using things like Copilot and Code Whisperer and Code Llama, like how are you using this on a daily basis if you're being productive? And they'll be like, oh, well, like I don't, write a sentence and get a function. Like that's silly. What I do is like if I'm in a library, if I'm in a code base that I'm less familiar with, and it uses a specific JavaScript framework that I don't fully understand its idioms, it helps me like tab complete through like completions of like I need to set up these things that are, you know, not quite required, but everybody sets them. And it helps you with the kind of the idioms of individual frameworks. But those don't demo real well because like you say, okay, here's a JavaScript framework that has like this like setting that you have to set all the time that says it's not really required, but it behaves weird if you don't. Like you've lost 90% of your audience unless you're at a JavaScript conference, in which case you just upset the other half of the audience because they think that that framework is terrible and no one should use it. And I think how we advertise these, how these are marketed and pitched, being so much different than like how people actually use them. I think, yes, and this gap between how it's marketed and pitched and demoed versus how it's actually used leads to this trough of disillusionment of like, we bought it to solve this problem and it's not solving these problems. And I think that gap, I think, is going to be the biggest thing, like challenge you have to overcome on like making these productive. And now I'm afraid that I've talked so much I forgot what your original question was. I knew I was going somewhere with this, but I forgot what your question was. I apologize.
It was about how are we going to fold like the serverless paradigms into this new AI thing, because they feel so different. One is very compute heavy, one is ephemeral, one has a weird state model, the other one we just offload to Dynamo as key value pairs. It's like they seem very different from one another, and like, how do we pull them back? Like, should we? Are we?
Yeah, and I think we will use like as we have like these things like the serverless framework and CDK and SAM and CloudFormation and Terraform. These have kind of populated different companies. Inside a large company, you'll have multiple teams using different frameworks, and you'll want people who can effectively kind of work on many of these. Like they work with CDK one day, and then like next day, if they're like helping a friend or they want to collaborate with them or contribute to a coworker's project, they don't have to brush up on Terraform. That generative AI can be used to kind of fill in the edges of this weird idiosyncrasy in CloudFormation or this weird idiosyncrasy in Terraform that can make it so that if you understand the first principles of like this is making AWS infrastructure and just help me kind of do the syntax correctly with like the weird idioms for this framework, I think that's where it'll be used most effectively. I don't think we're going to get to a place kind of separate from that where you have like a serverless Gen AI thing other than what
Oh, Midjourney.
Midjourney. I kept thinking Stable Diffusion, but that's not it. So, like, there are companies like OpenAI that does like you could call OpenAI kind of serverless as like a customer because you don't have to provision the servers for that. You just go to it with your request. It's like a function as a service, depending on how big your context is that you pass to it. And I don't think we're going to see like as a kind of wild example of like Lambda functions that have like H100 NVIDIA GPUs like attached to them with like all this kind of memory, simply because I think it's more of a practical reason right now. Like a lot of the benefits you get of kind of serverless compute, where you have this Nitro enclosed execution environment. It's much harder to do with like GPUs and make sure that the memory has been properly cleaned up afterwards for in the GPU cards for like the next inference that needs to come through there. The amount of time it takes to put. I mean, these are billion byte models that you're putting on there. They're tens of billions of byte models. Just moving that stuff in and out of memory is much longer than even the cold start latency people were upset about, like rightfully upset about. But like I think that there's enough technical kind of hurdles that we're not going to see something like Lambda functions that can run code Llama 70B on an average time.
Right. Yeah. That's I feel that because as I'm building AI programs, I'm doing a lot more in Python, and I'm using ChatGPT to teach me Python so that I can write Python code to build chatbot apps. And my like serverless take on it is using a service like Streamlit for Python and building apps and deploying them without um, actually spinning up massive compute clusters. um, I'm just making API calls over and over and over again, and I mean it's working pretty well. Like I'm pretty shocked at how well some of these chatbots can perform just through like little API calls here and there. But I haven't gotten like super deep into creating my own custom models and doing fine tunings and dealing with vector databases and stuff like that. So have you seen any really, I guess, standout or like really good examples of using Gen AI with like modern infrastructure tools?
Not, I don't want to be like, oh, the only good example is like the one that I built. So in my like fun employment time over the past couple of months, I have what I've been trying to do is take Code Llama and fine tune it on kind of sample code that I'd created to see if I can get a version of Code Llama that creates like recommendations that are based on like kind of my code, um, which is similar to what Code Whisperer customizations takes a RAG approach to it, where it requires chunking and tokenization and it goes into a database. And there's issues with that. There's this trade off that you need between if you do a RAG approach, it requires less data, and you can reuse the same model across kind of if you're a multi-tenant like architecture. Like everyone gets the same model, and then for a specific tenant, you insert context from the RAG for that specific customer. And I'm not certain on like it's really hard to measure quality on a lot of these items that come out of a generative AI. Like, how do you tell if an answer from you get two answers from a generative AI tool? Like, how do you score them? One's better than the other, or equally? Right now, it's a lot of like kind of judgment of like, yeah, it feels right, or like that's clearly wrong. I think that's about like the extent of it. I've seen some research on like how there's like known data sets that say here's things that you can do and approaches for that. And all this to say, I've been trying to like fine tune Code Llama, and it is tough. Like I think where companies like Hugging Face are really in terms of like on the infrastructure side to address your question, where they're really differentiating themselves is you've got like the model, like the GPU is attached to some, let's just say an EC2 and some computer. It's running Ubuntu 20, Ubuntu 22, Ubuntu 24, or Amazon Linux 2, or Amazon Linux 2023, right? So it's like 5 different operating systems. Just we're talking about AWS, and then the instance might have the A100, the H100 GPUs. Like I think there's like the P3 types. There's different types of GPUs, and when you try to reproduce like examples from either blog posts or from papers, it's a pain. Like we've known about like reproducibility in papers for a long time being an issue, but like I think I was just trying to get a VS Code extension to work on the EC2 instance I was running VS Code, and like, oh, we don't support that version of Ubuntu, and like I had to like recompile this thing like from source, like because they use like Rust with WebAssembly to make it multi-platform, but then like the platform I was on wasn't one that they targeted, and I think what Hugging Face does really well is with their I forget the term that they use for their like spaces that you can create code spaces or code spaces GitHub. There's another
I
the
think it
code
is just Hugging Face
spaces.
Spaces.
Yeah,
Yeah,
yeah, that's not,
we can launch like a full inference model on their hardware, on their cloud, on their platform.
yeah, and it gives you this like repeatability. So someone can say, "I've done this benchmarking with this infrastructure." You get a one-click button to like pick up where I left off or reproduce it. And until a lot of these infrastructure as code or like bigger cloud providers provide something like that, they're going to be drawn. Those big cloud providers are going to be drawn to just catering to like the big companies who want to do hundreds of millions of dollars worth of investment on like, oh, we will sign a private pricing agreement to buy so much capacity in H100s if you support X, Y, like these specific features. And you're not going to see like, oh, here's how to like fine tune your own code llama like 7B. Like that's just not going to be a thing that it's so far down the long tail that I think Hugging Face is really doing a lot of work to democratize that access today.
Yeah, I love Hugging Face because it's the one repository for all the open source models. I was using LM Studio as like a easy desktop application. You can go and browse models, install them, and just start chatting with them right away. What have you really enjoyed or found out about using Llama, the Llama code generator model? How are you finding it? I haven't tried it yet.
I like it. It's I've learned a lot more. Like I said earlier, on like I understand like the fundamentals of how these things work, but not too much on like how they're implemented or like how to translate. Like, I mean, we know how to go to like OpenAI and ask the question, but like if I were to give you like the model that OpenAI uses and say, here's a binary, like here you go, here's the model, it's all of the weights in this big, hundreds of gig file, like do an inference. I'd be like, I don't even know. Like, is it command line? Is it like, do I have to load it? Like, how does it? Like, do you have a Jupyter notebook I could use? Like, it's very deceptive to like read a lot of these papers. I'm like, oh yeah, I agree. I can see how this is going. Like, I get it. I get it. And then it's humbling to sit down in front of me, like, okay, now how do I actually like how do I poke this thing to make it turn? Like, how do I do that? And that's what I've enjoyed about working with the Llama models. They're not paying me for plugging them here. If they want to, I won't say no. But it has been good because like when they publish their models, they also publish like variants of them that are fine tuned for like code. They have like the Llama for code and Instruct, which is like explain this code to me, which I don't get too much into. But like they have code and they have like specifically a code for Python, so it's like fine tuned for generating Python code. And they also produce a lot of like example applications. Like if you wanted to fine tune it, here's how you could fine tune it yourself, which like saves me a bunch of time in like trying to set up like my own fine tuning runs.
Do you know the difference between like fine tuning and embedding? Because those are two different approaches, right? To like affect the outcome of a model inference. Am I thinking about that correctly?
My understanding is that like a fine tuning is like you train a model, right? You have a machine learning model and you have an input and it produces an output and then you score the output and then like the weights are you talked about learning the calculus and it back propagates through and adjusts the weights and you do this training back and forth. At some point they say, okay, we're done. Like it is done. here's the model, and they seal it up and they say it's done. And that's your foundation model. What you could do is there's a bunch of different types of this, but at a very high level, one way you say is like, well, I just so happen to have all this other data that they didn't have when they were training. Let me just kind of like pretend as if I were continuing the foundation model kind of pre-training process, and give it more data and have it run through and back propagate and do this a bunch of times until I decide that it's done and has enough accuracy with this new data I provided, which is my private data. And that's fine tuning. And there's a lot of different ways of doing that. Like the way I just described is called like full fine tuning because you can adjust all of the parameters. You could say that like I can't really load all the parameters, so I'm gonna treat like the first half of the model is like fixed and then only really do weight adjustment on like the second half of it, because that's all I can fit in the GPUs or for whatever reason. So that's fine tuning. My understanding with embeddings was that embeddings is like the tokenization, right? Where you have some data that you want available as like part of the context, and you use the tokenization to create a vector for that, and kind of store those in these vector databases, and then that's what's used so you can, when a query comes in, you can look for things that are most similar to that, and then take those items and embed that, like put that into the context, and that's the idea of like using embedding and the retrieval, like doing that kind of storage and retrieval at like runtime is like the RAG approach, but it's a type of embedding. That was my understanding. I could be way off on that, but that was my understanding of the difference between those two.
I think that makes sense. Like the RAG approach, retrieval augmented generation, right? It's more of a caching strategy to give the model to give the model, what is it, compressed context. It's like compressing the data that only the model can understand. Um, at the time of inference versus fine tuning is actually changing the model itself without having to do any kind of pre-computing caching of vectors beforehand. I think
Yep.
that's where it is. That's really cool. That's really cool. So in you mentioned Hugging Face, um, as a they offer some of the infrastructure for doing the fine tuning and doing the inferences. Are you doing these things like are you building this stuff locally, like on a big fancy desktop machine, or are you doing it all in the cloud?
So when I still worked for AWS, I did it in the cloud because I had access to like an employee account, that I could get access to a P4, P5 instance. Now it's locally. I have over here like a Jetson Nano. Let me see if I
Oh
can
yeah.
just. So it's a few years old. It's like I can't put anything consequential on there, but it helps me go through like the mechanics of how to, like loading a model, even if it's a very small, like I probably couldn't even get like a 1B model on this, but like something very small. So I understand like this is how the things are loaded and they're like sent to the CUDA and then like the response come back, for the mechanics of it. And then I am working on a PC that I had that I'm rebuilding that I'm hoping to get like a 4090 card for it, but I have to convince my wife that it's an investment in my employability and not just me buying a brand new graphics card.
I just wanted a nice GPU to play some games, and then Bitcoin happened, and I couldn't get it, and now AI is happening, and I still can't get it. I just end up paying my $10 a month to Google for Colab, to run a lot of these things on their Colab platform.
I am curious because I mean, there's a kind of the meme that's going around with like Sam Altman was asking for like $7 trillion for building a new chip factory, and I wonder if because like with GPU or with Bitcoin mining way back in the day, like the hype was like ASICs, like people would like I think Butterfly Labs was one that created it where they would like build like custom specific hardware, like that was like hardware optimized for like the specific like SHA-256 algorithm needed for like doing Bitcoin mining. And while that was like the way to like you could mine on a GPU, but these ASICs were like so much faster that it wasn't even worth it. It was just wasting electricity, and that kept some of this at bay. I think the GPUs got much better, and some of these ASICs provided like Kickstarter things ended up being like rug pulls where they stole everybody's money and ran away, or they like did a bunch of their own mining and then sent like essentially used cards out. That I'm hoping that if they do come out, I mean, we're talking another 10, 15 years though, but like AI specific, I don't call them GPUs because they're not kind of for graphics, like AIPUs or whatever you want to call them, that will decrease some of the pressure on like actual graphics cards for graphic applications. Like I don't want the next Pixar movie to cost 10 times as much because they are competing with venture capitalists for access to a render farm for, I don't know, Toy Story 38 or whatever number they're on now.
Right. I mean, the latest Intel chips, the new core chips have a neural processing unit with it. They call them like an NPU, and then Apple Silicon has their own AI chip. It's just like how quickly can we multiply giant matrices. Um, that's what they're for, and I'm looking forward to the APIs that are coming out of these hardware chips soon. Who knows? Maybe we'll get a browser compliant AI, interface. It would be cool, in the browser to call like on an image like dot recognize, and it would just give us nice little JSON of what the user uploaded. I could see that happening.
And I couldn't imagine like there's much more that would like require GPU or Chrome tabs to need even more memory than they already do. Like they're already like near the top end. Yeah, it's like, oh man, I can only open one tab at a time. So we're back in 2002 timeframe.
I mean, isn't technology just a ping pong game between fat client, thin client, heavy server, thin server? It's like, well, with the evolution of all the front end technologies, just making the front end heavier and heavier and heavier, and then people then saying, well, no, wait, we can do everything on the server, and then like make the clients thinner and thinner and thinner again.
Yeah.
Cool. So, we've talked about infrastructure as code, like the complexities of getting Gen AI up and running. There's still a lot to play with. There's still a ton of opportunity for people to jump in and learn. Um, do you have any like suggestions for folks that are kind of maybe just getting into this? We said RAG a bunch of times. It just means retrieval augmented generation. There's a lot of buzzwords, but like, how would you suggest that people get into the kind of stuff that you're doing?
I would highly recommend. So Andre Karpathy is kind of famous in the space for. I mean, he's worked at OpenAI and Tesla, and he's done some teaching at like Stanford. He has like on his like YouTube channel where he's like walked through like building essentially GPT like from scratch, and he starts with like a very basic neural net, and I think it's like 15 or 20 hours. He just came out with a newer one that talks entirely about embeddings and tokenization. That what I like about his teaching style is he explains like the math and like how it works, goes through like the manual process of it and then writes like very simple Python code to explain it. And he explains like this is why we're doing this like in Python, like this is why we're using this specific operation or this specific thing, and calls out parts where he's like, we're doing this here just because it's simple, but in like the real like PyTorch libraries, they will do it a much better, more optimized way. And it gives a real good like balance between the technical, like here's how to implement it versus a theoretical of like here's the math behind it. So and then you have a thing that kind of works at the end. I think that's a really good starting point for people because it doesn't assume any expertise of in Python or in calculus or any of these advanced linear algebra techniques or any specific educational background. So that's what I would recommend in terms of like getting started education, like learning wise.
Awesome. I just looked it up. Andre Karpathy. Let's build GPT from scratch in code. There's a whole series called Neural Networks Zero to Hero on YouTube, and it's spelled Andrej Karpathy, Karpathy. So
Yes.
that's an awesome. I'm gonna have to watch this now because I hadn't seen this before. This is great.
One thing I would caution anyone who watches it is that watch to the end of a video before you go off and do anything else. Is I want the reason I bring this up is there's a couple of times where he'll make a mistake and intentionally he'll leave it in, and then later be like, "Oh, there was a mistake. I didn't catch it, so I left it in to keep the realism. Here is the issue." And like I hadn't gotten to that part yet when I was like trying to tinker with it, and I was like, "This doesn't work. Like this guy's a fraud." I was like so frustrated, and then like I think I was like, "All right, fine. I'm just gonna." I'll finish the video series and then I'll send him a sternly worded email. And then like 2 minutes into the next video, it's into like the remainder of that video, he explains that, and I'm like, oh, now I feel silly.
See, that's the kind of hard hitting real world experience that our listeners come to the show for. Watch the whole video first.
Yes, and especially like when I was at AWS, I talked about like half quotes. Like you want to make sure that when you're talking to people publicly, not to phrase things in a way where it's like they could just use the first half or the second half of what you said and like take it out of context. And then I like did this to Andre, like, well, not like did it to him, but I was like, I only listened to half of what he said, and I was like, this man doesn't know what he says. Clearly well respected, like highly credentialed, like expert in the field. It's his fault, not mine. Yeah, so it was again like a humbling experience. I mean, I didn't actually reach out to him or like embarrass myself in any way, but I was like, I was frustrated for like a day, and I'm like, I don't get this. Like, this is it's all snake oil.
Cool. All right. Well, I mean, it's we've been having a really awesome chat, and I think now it's time to get serious with you, Richard. I know that you're a good mathematician, you're a great computer scientist, you've built open source tooling, but the real question is pancakes or waffles? Which is better?
Oh, waffles, definitely, like 100%. Yeah.
Tell me about why, but you got to bring out a whole separate iron, like a whole separate device in order to make the waffles. With pancakes, you got the batter, you got a pan, you're done.
Yeah, but I mean, what I like about the waffles is like it has like the individual wells, so you can decide like, these are the peanut butter wells and these are like the syrup wells, and you control like when they mix or don't mix. With pancakes, it's like a mountain of like pancakes, and then everything just kind of poured on there. It's a huge mess, and like there's a lot of skill required in like good pancakes. Like people always talk about like the first pancakes to throw away one that you make it and you throw it away. I don't know how true that is because I don't like the pancakes, but like waffles, like it is a separate tool, but it has like a timer, so it gives you more consistent results. And like if you over pour a pancake, it's going to be either deformed or not shaped right. It's not going to sit on the plate right. With a waffle, if you over pour, it just comes out the side and ends up on the bottom. Your waffle is still the same size, so you get like consistently same size waffles every time, much more easily than with pancakes.
I love that answer because it still like it is so on brand for you in our entire conversation. It's about, reproducibility, it's about consistency, it's about adding the option of high dimensionality if you wanted. You could have a higher dimension waffle by segmenting, the grid. Yeah, I love that.
Because you could pour the batter into just one corner of the waffle maker and you can have a quarter of a waffle. You can't make a quarter of a pancake. Like you just get a smaller pancake.
I love it. I love it. That is
Because you could pour the batter into
those
just one
are
corner of the waffle maker and
true
you can have a quarter of a
technical
waffle. You can't
architecture
make a
decisions
quarter of
that
a
I hadn't
pancake.
considered
Like you just get a
in
smaller
in
pancake.
waffle making. So thank you for that, and I hope our listeners also take the time to really consider their architectural decisions on waffles or pancakes.
Yeah, so the takeaways from today's video are watch the whole video and always choose waffles. Like those are the two takeaways from today.
And AI probably isn't going to replace us anytime soon.
True.
All right. Well, and with that, Richard, do you have any final shout outs or things you're working on, things to promote, where people can find you?
I'm on Twitter, Richard Boyd, with all of the vowels removed except for the Y in Boyd. So I'm
We
trying to
could put
think
a
of,
note in the show notes, I guess.
yeah, it's kind of like a riddle.
All right, well, it's fine. It's fine. Find you on Twitter.
Yeah, so I've been on this kind of like fun employment break, so I'm just kind of lounging around and working around the house. Um, trying to be on social media less than in some of my like previous jobs that required me to be a bit more active, but I'm still there if anyone needs anything. DMs are open if anyone has any questions. Anyone wants to send me an angry DM about half a video of mine that they watched, happy to receive that. That's my penance. Um, and yeah, hopefully someday I'll go ahead. Come join me at Company X, where I now work and I am gainfully employed and I'm making lots of money with lots of benefits. But until then, I just kind of exist in the ether.
Fun employment is a interesting place to be. I've been there a couple of times myself. So with that, thank you so much, Richard, for coming on the show today. Really appreciate your time and experience and thoughts on waffles, finishing the video, rag architectures, embeddings, working with Llama, you know, all of that stuff. And thank you so much to our listeners today. You've been listening to Talking Serverless with me, Paul Chin Jr., where we talk serverless with people. Go ahead and smash that subscribe button, hit the likes, join the socials, leave a review. If you hate the show, leave a review. If you love the show, leave a review. And with that, we will see you on the next episode. Thanks so much. Bye bye.